Hi, this is Tadressa. Welcome to a complete course in calculus. In this section, we'll talk about derivative. So we'll define what is derivative, what is the reason behind this notion, this concept, why do we need this derivative, and what is differentiation means, what are the different notations we'll be using for derivative. So let's start with a simple graph. Let's say I have a line, a curve here, which I would say f. This is the graph of f, any function. Now I have a line L. This is the line L, which cuts the graph at 2 points. Let's say this is C1, this is C2. So this line is called secant line. Secant means it came from a Latin word secar. Secar means cut. Okay, so this line is cutting the graph of it. Now, the question is, if you ask me, what is the slope of this line? The answer is, okay, if this is C1, this is f at C1, and this is C2, so the y value will be f at C2. So what is the slope of this secant line? The answer is, you know that slope is defined to be rise over run, or we call it change in y divided by the change in x, or we call it vertical change divided by the horizontal change. So what is the vertical change or the rise? It is y2 minus y1. Horizontal change is what? x2 minus x1. So if you want to write y2 and y1 in terms of function notation, or if we are using these points, C1, C2, this is what your y1 is, this is what your y2 is, this is your x1, this is x2. Let's use these points. So this becomes f at C2 minus f at C1 divided by C2 minus C1. That will be the slope of the secant line. Now the question is, instead of having two tangent lines, let's see what happens. You see this distance, this difference, the difference between C2 and C1, which is nothing but this guy here, C2 minus C1. I'm gonna call it change in x, right? So now let's see what happens to that secant line as change in x goes to small. So this is what the line is, the original line. Now instead of C1, I'm just gonna call it C, and this is what I call it change in x. So if this is C and this guy is change in x, so this becomes what? C plus delta x. Now this is the function f, this is the line f. Now look what happens. Instead of passing through C and C plus delta x, if I draw another line which passes through C, of course, but the next line is, the next intersection point is this one. So now this is my new, I call it C1 plus delta x. Now my delta x is not this delta x, it is this one, which is new delta x. I call it change in x1, okay? So now if you keep doing that, what happened is this change in x goes to what? 0. So goes to 0 means the line becomes a tangent line. Just it becomes tangent line. So tangent line means what? The graph touches the line, this line touches the graph of f exactly at 1 point. Now the question is, how do I find the slope of this line, which we call it tangent line? The answer is, this line becomes a tangent line as change in x goes to 0. And I showed you before, the slope of that secant line is nothing but change in y divided by change in x. So this becomes the limit of y2. y2 means f at x2. What is x2? C plus delta x. okay, minus, you see, c plus delta x. This is what y2 is. C plus delta x, the value of c plus delta x, which is f at c plus delta x, minus f at c divided by c plus delta x minus c as delta x goes to 0. If this limit exists means what? If the right limit of this guy, this expression, which we call it the difference quotient, right hand limit of the difference quotient is a real number, left hand side limit of this difference quotient is a real number, and both right and left are the same, in that case we call this the slope of the tangent line. So we started from a second line. Now we were able to find the slope of the tangent line. So this guy can be simplified. You see here, c minus c is 0. So this becomes the limit of f of c plus delta x minus f of c divided by change in x as change in x goes to 0. So if this limit exists, we call it the slope of the tangent line. Not only the slope of the tangent line, we also call it the slope of the graph of f at c. So we use it interchangeably. So when I say find the slope of the graph of f, find the slope of the graph of f at c, I mean find the slope of the tangent line, which is nothing but this limit, if it exists. Very good. Let's see an example. Let's see an example. Example. So we want to find the slope of the tangent line, or I can say find the slope of the graph of f. Find the slope of the tangent line to the graph of, let's pick a quadratic function, f of x equal to 3x squared plus 4 at c equal to 2. So we want to find the slope of the tangent line to this graph, to the quadratic function at c equal to 2. So what you need to do is, let's calculate the limit. So if the limit exists, limit of f of c plus delta x minus f of c divided by delta x as delta x goes to 0. So this will be what? Limit of, what is f of c plus delta x? Now the value of c is 2, right? So I'll plug 2 plus delta x minus f at 2 divided by delta x goes to 0. Now look at this, it says f at x is what? 3 times x squared plus 4. So I have to find f at 2 plus delta x. So that will be equal to what? Limit of 3 times 2 plus delta x squared plus 4 minus, what is the value of the function at 2? At 2, 2 square is 4. 2 square is 4. 4 times 3 is 12. So if you want, I'll just write it plus 4 so that you can follow. Delta x goes to 0. Everything divided by what? Delta x. So this gives me what? Limit of 3 times. If you FOIL this, 2 plus delta x squared means what? 2 plus delta x times 2 plus delta x. That will give me what? 4 plus 4 delta x plus delta x squared, close the parentheses, plus 4 minus, now if you see this guy, 2 square is 4, 4 times 3 is 12, 12 plus 4 is what? 16. Divide everything by delta x goes to what? 0. So this is equal to the limit of 3 times 4 is 12 plus 3 times 4 delta x is 12 delta x plus 3 times delta x square is 3 delta x square plus 4 minus 16 divided by delta x as delta x goes to 0. Now let's simplify it. 12 plus 4 is 16. 16 minus 16 is 0. So this cancels out. So what's left? Limit of 12 delta x plus 3 times delta x squared divided by delta x, as delta x goes to what? 0. Now, what is common here in the numerator? You can see that delta x is common, so I will factor out. I know 3 is also common, but let's leave that. Delta x, 12 plus 3 times delta x divided by delta x goes to 0. So now the delta x cancels out. That will be 12 plus 3 delta x goes to 0. So now as delta x goes to 0, this guy becomes what? 12. So the limit exists. So which means what? The slope of the tangent line to the graph of f of x equal to 3x squared plus 4 at c equal to 2 is 12. Or I can say the slope of the graph of f at 2 is 12. Okay, so now one remark over here is what happens if the limit of that difference quotient c plus delta x minus f at c divided by delta x as delta x goes to 0 equal to either infinity or minus infinity. Now, if this function f is a continuous function, so continuous means what? Continuous at c. If this function is continuous at c, then the limit goes to plus or minus infinity, means we have what is called a vertical tangent line. So x equal to c is a vertical tangent line. That's what it means. So geometrically, this means I have a graph of f. So you see at this point C, right, I have what is called a vertical tangent line. This is what we call it, vertical tangent line. So it touches the graph exactly at this point. So if you calculate this, the slope at this point at C, the limit will be, the limit of the difference quotient will be what? Plus or minus infinity in that case, because this function is continuous at C, then we say that it has a vertical tangent line. Thank you for listening. I'll see you in the next video.